Okay, so we're going to complete the square on x squared plus 6x plus 10. And we're going to make use of our perfect square that we've used lots of times already, which says that I've, over in blue here, that I've x plus a all to be squared. It means I square the first, giving me x squared, twice the product, giving me 2ax, and then the square in the last, giving me a squared. Okay, so we're going to use this process, but we're going to try and work it in reverse. So we're going to start off by writing down x squared plus 6x. The next thing we're going to write down then is we're going to add and subtract half the coefficient of the x term. Now the x term coefficient here is plus 6, so I'm adding on plus 3 all to be squared, and I'm going to subtract plus 3 all to be squared. And you'll notice I'm still leaving the sign in the bracket because that will help us out in a second when we're going to write our perfect square. And then I also have my plus 10. Now obviously mathematically I haven't changed this because I've added and subtracted the same thing in the middle of the expression. So next thing I do is I take the first 3 of those, and they are what becomes our perfect square. So I write that as x plus 3 squared. I still have to take care of this next part here in red. So that's minus, now we've plus 3 to be squared, which is 9. Okay, so that's that. And then finally then, there was also a plus 10. Okay, so then I have x plus 3 squared, and I have my minus 9 and my plus 10, which is going to give me plus 1. Okay, so now I've completed the square on x squared plus 6x plus 10. And I've written it in the form x plus 3 all to be squared plus 1. Now this can be handy for several reasons. It's now in vertex form, so we can clearly see that if I was to sketch this function, so if this was called f of x equals x plus 3 to be squared plus 1, I would know that I would need to move it 3 to the left and go up 1. So it has a vertex somewhere here that is minus 3, 1.